Okay, people. So I think the attendance is on. Everybody is entering their names. Okay. Anybody having problems? Anybody having any problems with the attendance? So if you have any problems, just see me after the lecture. I will let you sign. What question?
About attendance. I'm first trying filling attendance. I'm ill before this week, so I'm not sure I can do it.
So see me after the lecture. Okay. So you missed the first 2 weeks of the lectures?
No, only 1 week.
Okay. So last time I think we were talking about this assert macro, and we said that it's macro, and people have been asking me questions about the defines and the macros and etc. As I said, I mean, this is a C thing. You're supposed to know all these. Maybe they didn't teach you, but you need to know about these. I'm not going to teach you everything about C++, but you're supposed to know whatever necessary for you to learn about C++. As I said, if I try to teach all the stuff about C++, that would take 2-3 courses, and that would be really unnecessary because most of the stuff are like these kind of stuff that you can read and learn. Okay, so the macro is something like this, like a function definition, but the difference between a macro and a function is that the macro is handled by the preprocessor. Okay, the preprocessor handles all the macro stuff. So when I say I am defining a new macro, its name is sqr square. Okay, whatever the parameter is given to it, it is x. As you see, it doesn't have any type because preprocessor doesn't know anything about C, right? Preprocessor doesn't know about types. Preprocessor doesn't know about C statements. Says that whenever I see square parentheses something in it, I will replace it with this. So when you say a square 2 plus 1, the preprocessor will replace it with 2 plus 1 times 2 plus 1, which is not the thing that you wanted. That's why we keep doing stuff like this. Okay, let's parenthesize these parentheses, parentheses, and parentheses. Okay, this way it will be safer, so it will be like this. Okay, like these kind of macros, assert is a macro too. It is defined by the assert.h. It was assert.h in C, but in C++, of course, it is C assert.h. Okay, and it does whatever we said last time it would do. It would check the condition. If the condition is right, then it continues running. Otherwise, it terminates your program. But as we said before, assert is only valid if you compile your program in the debugging flags with the debugging flags on. If you compiled your program with this flag, define no debug, okay, define no debug, then assert is automatically turned off. That line is not compiled at all. So this line in your program will go away if you compile your program that way. So that would be very useful in debugging your programs, and it would go away when you try to deliver your program, your library to the customer. Where is my microphone? I don't have the microphone. Somebody has it. Oh, okay. Do you guys? Let me see if my. Okay, I think it is. Okay, I will speak louder then. Okay, so that's the whole thing about macros. Remember, we were talking about this at the end of this chapter. Okay, we started talking about this testing and debugging. We said that we could use lots of printfs, couts. Okay, and that would be nice, but we have to delete them once we make sure that there are no bugs in our program. But later, when we made modifications and introduced a number of bugs, then we need to put them back in to prevent these kind of putting your cout scenes in and putting them back in. So we said that why don't we define this no debug thing? If no debug is not defined, then print this out. If no debug is defined in your program, then this line will not be compiled at all. Okay, and no debug is automatically defined if you compile it this way, or if you compile with your optimization flags on, and etc. Assert is something like that, and if you like to do this stuff with an assert, then do it that way. So we talked about this lots of CL statements, compiler debugger, we talked about it. We talked about assert macro. Finally, let's talk about stubs and drivers. I think you know about this, but let's kind of make a review. Okay. Okay, stub is this. Okay. Okay. So we develop our programs incrementally. Okay. Nobody sits down on his or her computer and writes the whole program. Okay. Writes the whole program. One by one, line by line. Okay. We need to plan it. Okay. Let's say I have a function. Okay, I have a function named unit price. It is supposed to, let's say it's a pizza. Okay, given the pizza diameter and given the square centimeter price of the pizza, I want to return the value of this pizza. So I am going to calculate the total area of the pizza and multiply it with this number price. Okay, so I need to implement it, but before I implement it, okay, I need to make sure that this unit price is used correctly in my program without implementing anything. So I just return a random number from this function stub. Okay, I know that this number is not correct. I know that it is logically wrong to return it, but this function will be very useful for me to test the rest of my program, to see if everything compiles, to see if everything comes together. So this is called a stub. Okay, you are basically you are stubbing out your functions until implementation. You just give, their headers, right? What was going what's going in your function and what's coming back, and you can call this function anywhere you like, and this program should compile. If it doesn't compile, then that means that there is something wrong with your program. So that at the early stages of your program development, that would be a very useful thing to know. Okay, so that's what we do with the stubs. That's called stubs. Okay, write functions whose headers okay, and return something not that meaningful, or you can return something negative number 2, and use this function until the rest of the program is ready. When the rest of the program is ready, you make sure that everything comes together, everything compiles and links and etc. But you know that your program output is not correct, then you come back and you implement this. That's called stub. Okay, so it's an example for development of your functions or your programs incrementally. Something similar to stubs is driver programs. Let's say we did it the other way. Unit price is implemented. Okay, I guess you are going to use this program in your pizza store automation system. Okay, you have a website that you are letting your customers order pizzas. Somewhere in your program, you are going to use this function. Okay, you'll get the diameter of the pizza and the price of the pizza, and you are going to do this calculation. Simple, but it's still simple. Doesn't mean that it is easy. Somebody has to type this up. So I have written this, but I don't know if it's going to work or not, right? So driver program is a dummy main function. Okay, it's a dummy main function. You write this main function just to test this unit price function. Okay, so this driver program, driver function main, it says that I need a diameter and price and answer. I am asking the user to give me a price and a diameter. I get them, and I send them to the unit price, and unit price is going to give me the result, and I will print it out, and I will ask the user test it again. So I have written this 24 lines of code, okay, or 9, 20, 15, 16 lines of code just for testing this unit price function. So that's called the driver program. Driver programs are not delivered to the user, end user, okay, to your customer. They are for you to test your functions, okay. Kind of opposite of writing stubs. Remember what was a stub? Stub is you return something, a number, a random number, so that you see if your program is compiling. Driver is something, you know that you have a function, it is compiling, okay. You are just testing it in some program, okay. I am sure you have tested both of these ideas, stubs and drivers, before. Lots of printouts, you have been doing that already. Compiler debugger, I ask you to use some kind of a debugger, Visual Studio or something else. I guess that's it for the whole chapter. So in this chapter, we talked about call by value, call by reference, overloading, and that kind of stuff. We didn't talk much about C++ or object-oriented programming, but I think these were necessary for us for our later chapters. Okay, any questions? So let's do some, where is my attendance? Okay. Good. I should find a easy way of doing this. I'm going to find it. I will ask Ilhan. Okay. Where did it go? Here it is. So let me go to all the way down. Is Ali Asım here? Ali Asım. Okay. Bilal here. Bilal Gökçe. Bilal Gökçe. How many Bilals do we have? 2. That's it. Good. Burak Kurt. Rabia Budak. Rabia, do I keep asking your name all the time? Is this the second time, third time? Okay, I learned your name. Reşit Aydın. Yunus Emre. Okay, I think this is Sümeyye is the first one. Okay, congratulations, Sümeyye. You have beaten everybody by 1 second. So it takes you 50 seconds to. Sümeyye is a fast typer. Where is Sümeyye? Sümeyye, okay, congratulations. Okay. And Ali Asım, okay, so for the last 5 minutes, okay, we are good. Okay, so how many people did not sign? 1, 2. Why did you not sign? You guys did not sign. Why? You forgot, or you came late? Okay, so see me after the lecture. Good. Again, we are going to take another attendance in the second class, so that whoever comes late, they have a chance to sign up second time, but everybody has to sign it. So I think this is fair. It is fair for me. I mean, I don't. So let me start our next chapter, which is about arrays. I will be again quick about arrays too, but first I need to find lecture. Where is? Okay, classes, arrays. Yeah, here it is. Okay. Yeah, there it is. So with the arrays, actually, I mean, arrays are exactly the same as in C, no new stuff. So this is going to be kind of a review, and using the arrays with some C++ notation, and that would be it. People are sometimes confused about arrays. They say that arrays are difficult, arrays are such and such and etc. But I say that arrays are no different than simple integer types. Okay, when you say I have an integer I whose initial value is 7, okay, when you run this program, the compiler will give you some space in the memory and will put this number 7 in it. Okay, that's it. So the compiler knows the address. When you say, okay, change the value of I, it's going to change it. Add 7 to I, okay, so compiler will produce code. That code will take this number 7 from the memory location, and it will use this plus operator to add 7 to that number. So 14 wherever you use it. Or if you do this, it's going to be okay. If you use this, I have another integer k, okay, then compiler is going to do this. K is here, and its initial value will be the same as I. Initial value of I is 7, so k will be 7 too, etc. What I'm saying is that when you declare a new variable such as integer, you declare it, compiler gives you some space, then there are things that you can do about your integer, such as addition, subtraction, and etc. Okay, assignment, whatever. Arrays are the same thing. Okay, you are saying that I need an integer array, which means that I need some space in the memory for 10 integers, and their initial values will be 1, 7, 3, etc. dot dot dot 10. I put them all together. So compiler says that, okay, here's your space. 10 positions. I am going to put these numbers for you. 1, 7, 3, 10. Okay. And there are, after that, there are things that you can do with this array. Okay. Its name is array now. When you say array square brackets 5, compiler says that, okay, I know this notation. Okay. I can use a square bracket operator, index operator on arrays. So the programmer wants me to access the index number 5. So it's going to be 0, 1, 2, 3, 4, 5. At this location, I am going to return this number. So this operator is valid for the variable named array. Okay. Variable named array. This notation is valid. But if you say this, I square bracket 3, the compiler will tell you that square bracket operator, index operator, is not usable with an integer, right? It is not valid. Okay, so you will get a compiler error for this line, but not for this line. So I put them in squares, rectangles. Green rectangle means that it is okay. Red rectangle means that it is not okay. Okay, this notation is valid too, right? So you see the greens and reds, right? Okay, this notation is valid too. Okay, you say ARR plus 2. The meaning of this plus and the meaning of this plus are very, very different. It is overloaded, obviously, right? Okay, this means it is integer addition. Okay, this means that take 2 away from 7, right? The result of this operation is another integer, and it is 5. The meaning of this is what? The meaning of this ARR is actually, I will take it as a what? ARR is, can you wake him up? Wake up. What are you doing? Yes. A pointer, right? ARR is a pointer actually. It points to this location. When you say ARR plus 2, compiler says that ARR is an integer pointer. It points to this location. Plus 2 means that two integer locations forward from the current position. So this is ARR plus 0, ARR plus 1, and ARR plus 2. So this statement produces a pointer that points to this location. As you see, we are using the same plus, but the meanings are different. And the meaning of this minus is different too. Okay, this is ARR 0 plus minus 0. This is ARR minus 1, and this is ARR minus 2. Okay, so it is going to point to that location. Well, you might say that what is at that location? I don't know. I mean, this is a bad mistake, actually, logical mistake. You shouldn't point to the location that you don't know what it is. Okay, so what all I am saying is that array definitions are like integer definitions. You declare them like this. It is integer declaration. Of course, for the arrays, they have their own declarations. And after you declare them, you start using them. But you don't use them exactly like integers. They have their own operators, like the index operator or the plus operator. The meaning of plus is very different than integer plus. Like the meaning of double plus is very different from integer plus, right? Okay, so we said that this operator is only valid for the arrays. Okay, it is only valid for the arrays. Again, this dereferencing operator is only valid for the pointers, and in C we use pointers and arrays like the same thing. So we treat the array names like a pointers. They are like constant pointers. You cannot change them, right? That's what happens. So this is not valid for an integer. When you say dereference I or times I, it is the compiler says what is it? I don't know what this means. Okay, so you will get a compiler error. This is okay. Dereference ARR. This is okay, but this is not okay, right? Minus. This is a unary minus integer minus. So it just takes the negation of the integer. What is minus ARR? It doesn't make any sense. Or plus ARR. I can assign values to integers, but you can't assign values to array variables, right? Because ARR is an integer pointer, but it's a constant integer pointer. You cannot change its value. Okay? Of course, both of them are nice. This will print 7 on the screen. How about this one? What does it going to print?
Address.
Yeah, well, it is going to print the starting address of the array, right? So this is not going to print the whole array. It's going to print the starting address of the array. Okay? And if you like to do that kind of stuff, okay, of course it's going to work. Okay, integer pointer P, its initial value will be ARR, the same address, yes. But you can't do that because ARR is a constant. There are two problems here. One is you are trying to assign an integer to an integer pointer. The second one is ARR is a constant. There is only a single problem here. You are trying to assign a valid pointer, but ARR is a constant. You can't change its value. Okay, so that's a small review of arrays. As I said, by this chapter array, it means that I'm going to introduce a new type for you. Okay, its name is array, and it is declared this way. Its meaning is keep same typed variable somewhere in your memory. You know its length. Okay, how many MS in it, and there are things that you can do with the arrays. The most common thing that we do is the array indexing, right? We index arrays. That's the power of the arrays. We can index them. Once you start using indexes with the arrays, especially when you do this kind of stuff, when you say instead of I3, when you say IJ, right? You keep changing the value of J in a loop and in a double loop, a nested loop, and that's array. They start getting powerful. Okay, you can do many things with arrays. You can represent matrices. Okay, with the arrays, two-dimensional arrays, three-dimensional arrays. You can do matrix multiplication, etc. By the way, did you hear the news? They found a way of multiplying the matrices 30% faster using some artificial intelligence technique. And now, I mean, do you guys know that somebody in the 70s, he invented a matrix multiplication method that multiplies two matrices using, I think 2 by 4 matrices. Instead of 8 multiplications, he said that you can do it with 7 multiplications, and that was kind of a revolution in the mathematics world. Now we are saying that for the large matrices, we can do it 30% faster. That's kind of a revolution. It happened last week. Read about it. Read about it. And we use, where is it? Do I have the paper? News. Go to Google News and type matrix multiplication. Yeah, here it is. Okay, so the same company, DeepMind, that Nature is a very important journal, scientific journal. Okay, so if you have a article appearing in Nature, it means that there's something major. Okay, it's the same company, a Google company. Google bought it. They remember the Atari playing computers, a computer starting from zero, and starts learning playing Atari games, and it is beating most of the humans. Okay, so this guy, he says that okay, the algorithm invented how to multiply two matrices faster. We don't know how it works, and we never know how deep learning works. It is using deep learning. That's the thing, but it multiplies better, so nobody can have an objection. So that means that all the matrix multiplication stuff is going to change. They will be 30% faster, and this is happening like very major development, and this is happening like once a 50-year stuff. I think the last time it happened like maybe 50 years ago. Okay, so do I have any other? Yeah, these are all, again, DeepMind people. Read this article, read the interview about that guy. Okay, so this is what they did. Tensor algorithm. So the number of multiplications here is 30% less than the classical algorithm that we have been using. And this order, this is just simple order, right? This order is invented by the reinforcement learning AI stuff. So why suddenly I started talking about this? Arrays are so important. We represent two-dimensional arrays with it, and matrices are very important structures for all kinds of science and engineering. Everybody uses them. Okay, they are used in computer graphics. They are used in scientific computing. Bioengineers use them. Electrical engineers use them. Medical scientists, they use them. So they are so important, and this is as simple as representing them in memory and doing some multiplication stuff. Okay, yeah.
If we say ARR square root is 2 plus equal to 3, let's say, the actual value of it is changing, right, in the memory.
Which one?
ARR square root, let's say 5 plus equal to 5, if we say that.
We don't say plus equal to plus assignment, you mean?
Plus assignment, sorry, yeah.
Okay, because there is nothing. Okay, say it again. ARR plus assignment
equal to, let's say, 5. But ARR square.
You don't say equal to. They are not equal to. Okay, it is. Okay, this is not equal assignment. To. ARR plus 2. You see. Now you can. Assignment doesn't work with ARR because ARR is a constant pointer. You cannot change the value of ARR.
I mean that ARR square brackets, let's say 5.
Oh, okay. So yeah. I type it wrong. So ARR square brackets 2 plus assignment 2.
Yeah, if you say that, the actual value of it is changing, right?
Sure. ARR square bracket 2 means that, okay, address 0, 1, and 2, this location. So you want to add 2 to it. You add 2, it is 5. And you want to put it back to this location, yes?
Yeah, if you say I plus assignment, I plus 7.
I plus 7, yeah.
I plus assignment equal to I plus 7. Yeah.
I plus 7.
If you do that, is the actual value of I is changing, or is there exists the...
Well, what is the difference between this and this? It's the same thing. I mean, I need to calculate something at the right-hand side. This is what I have calculated. Then I assign this value, okay, to this one after adding it to I. This one doesn't care what you have on the right side. It is calculated and it's a value, okay? Doesn't matter if it is coming from I plus 7 or just 7. Remember the expression tree? What is the expression tree for this one? It is plus assignment I and plus I, and here it is 7. And let me get this integer out of here a little bit to the right. Okay. So this plus assignment doesn't know where this result of the right hand side is coming from. It doesn't care. Okay. Or it knows that this will be done and I will assign that value to I after adding it to I. Yeah.
Why this pointer is constant?
Arrays, why are they constant?
Yeah, why is there any reason?
Anybody has an answer? The first answer is I don't know, I don't care. That's the rule of the language. But after that, yeah, it is something that we should do all the time. Then why did they make this decision in 1974 when they designed the language? Why did they make it constant? Yes.
We don't want to miss any.
Because if you keep changing the ARR value, who's going to remember where the array is? Okay. I mean, you say that, okay, I'm a C programmer, I am smart. If I'm going to make that mistake, that's my mistake and I accept it.
Yes.
Okay, that you might say that, but that's not a good programming style. I mean, keep ARR constant. That way, compiler doesn't, ARR doesn't have a, okay, this is the starting position of this array, okay? And you don't want to miss this location. And ARR is not like a, see, this is a new pointer P. P has a new location in my memory, okay? And I can change that value.
Can't change.
Yes, so you could. Okay, let's say this, and this is my P, okay? When I say P has the initial value of ARR, I don't know, let's say this location is 0xF2B2. So I put 0xF2B2 here. So I can change anything. I can change the value of P anytime I like. That's my pointer. But the same thing is not true for ARR. ARR is fixed. It always has to point to this location. And compiler can do lots of optimizations, knowing this fact. ARR is a constant, so I don't have to get the value of ARR from some memory location, right? Since it's a constant.
Okay, but we can't increment this error value, right?
No, you can't. No, you.
We do that.
No, this is not valid. I mean, when you say, okay, let me write it too. ARR plus plus is red. You are incrementing the value of ARR. ARR plus 1 is okay. ARR plus 2 is okay, right? But ARR plus plus is not good. Okay? P plus plus is good. Here. P plus plus. P plus plus is good. But ARR plus plus is not good. Because P has a memory location that I can modify. Yes.
Can I use malloc and would it change the value of our ARR?
Malloc was going to give you a memory location, okay? What are you gonna, it's a pointer, right? What are you gonna do with that pointer? You can assign that pointer to some pointer variable, but the ARR is a constant. You cannot modify ARR. If you are thinking about if you are thinking about making this array larger or smaller, no, you can't do that. You need to allocate some new space, some space, and you need to copy all of that stuff to new space and deallocate this one and etc.
So
Yes.
I'm thinking about stack, and if I want to pop and push stuff, can I use ARR++ for pop and push?
Well, ARR plus plus as first of all, ARR plus plus is not doable. It is a compiler. You cannot modify this ARR, right? It's a constant. If you are saying that ARR plus one, can I? You are saying that can I push more data to my stack using ARR plus one kind of? Yeah, and remove some stuff. Well, if you like to access your stack in that way, like integers, yes, you could. But that's a dangerous way of dealing with your stack because you don't know what kind of data you have in your stack. By the way, remember the buffer overflow vulnerability, buffer overflow, stack overflow, right? They are doing exactly what you are saying. I know that this pointer is pointing to somewhere in the stack. If I increment this pointer one by one, I will access the stack, other positions at the stack, or the positions that I should not access. Once you start doing this, and you can do many good and bad things too. But those are again dangerous stuff. They are compiler dependent, architecture dependent. For a good programmer, nice programmer, okay, you shouldn't write those kind of programs. Yes.
Can we change the volume of array?
The size of the array?
Yeah.
No, that's what I said. No. Once you say it is array of size something, it is allocated that way and it stays there. That's why we like this vector class. When you say a.resize, right? It automatically changes its size, our vector, okay? What is going on under the hood, we don't know, we don't care. We say that I used to have a vector of size 10. Now I resize it. It is a size of 100 now. That's very nice, right? That's the reusable, nice and clean interface class. And those are the type of classes that you need to write because those are the easiest to work with. I can abstract away all the details of the complications of underlying data structure. I just say resize and it resizes. I just say push back one element to the end. It just pushes back one element. I don't care if it is allocating, reallocating, deallocating. I just use it. But the same stuff is available for all the languages, especially easier languages like Python. You don't care what's going on and you're just using it. That's why it makes it so simple to use. But in C and C++, if we like to, we can design our efficient classes like those. And if you like, I can dig deeper in the class and I can see what's going on. I can write optimized code for that class too. Yes. What happened? Why are you asking so many questions? Something happened. Yeah.
Can you create an array with all elements are empty or zero?
An array definition. Well, that's it. When you say integer why can't I? Okay. When you say integer pointer IP, here's an integer array for you. It has 0 elements in it. It's just a pointer, and I don't know where it is pointing to. Very dangerous thing, but as I said, it has 0 elements in it. Okay, but if you wanna say integer IP square brackets 0, probably it will compile. But again, since you won't be able to change the value of IP, it is not anything useful, okay? It doesn't point to anywhere you want. You cannot change its value. You cannot put anything in it. There is nothing useful will come out of it. Okay, good. So this simple slide, okay, I assume that you already know the arrays. That's what I am going to assume. Kind of summarize what we know about, or what we know about the arrays, and we looked at some of the stuff. By the way, oh no, I'm not going to talk about it. I'm going to talk about it later. Okay, so this is the beginning of the chapter. It says introduction to arrays, arrays in function, and etc. So I'm going to give you a few examples and one or two C++ 11 related stuff about arrays. We are going to talk about it. So I like to make a separate discussion about this. This is our first aggregate data type. What's an aggregate data type? Arrays, as I said before, they are similar to integers or doubles and etc. You declare them and you use them, but they are special too because they are aggregate. What is aggregate? They group a number of variables together. Okay, you say that I am going to have 10 integers. I am going to group them. Okay, put them together in the memory for me, and I am going to call them ARR. Okay, that's an aggregate data type. In the arrays, whatever I am aggregating, whatever I am grouping, they all have to have the same type. They are all integers or they are all doubles when you say double AR2. Okay, so whatever you are aggregating, they all have to be same type. In the memory location, it's going to be like 10 integers, 1, 2, 3, 4, 5, 10, and they are all integers. You can say that 3 of them will be integers, 2 of them will be doubles, 5 of them will be etc. and etc. You can't do that. Okay, so it's going to be same type. Okay, integer, float, double, character, etc. These are all could be the individual elements of the array. Okay, it says simple data types, but it could be a complicated data type. Too. For example, I can say string. I will have a string array. And I need 10 of them. Okay, so S array is a array of strings, and each one is not a simple type anymore. I don't know what is going on inside a string, but I have 10 of them in the memory, one after the other. Okay, and we keep lots of stuff in it. Good. So declaration of the arrays and the usage, you already know that. Indexing of the array starts from 0. Okay, so this is ARR0. Does anybody know why we start from indexing 0 instead of 1? Starting from 1 is something somebody from high school expects. I mean, if you are counting something is 1, 2, 3, 4, it's not 0, 1, 2, 3, 4, right? Why do we start from 0? Yes.
Because the value are put holds the address of that points the address of the first element.
Yeah.
So if you increment with 1, you will get second element. If you increment with 0, you will get the address that you point.
Okay, you are saying that to access the first element of this array, you need to do something like this. ARR plus 0, that's going to give you this location. Yes. And if I dereference it, I will get the first element of the array. Okay, so I am adding this, but why don't I add 1 to it so it is more logical? Like the first element is ARR1. Why do I have to add? I mean, I am adding a 0. Why am I adding a 0? I can add a 1.
But ARR holds the first address.
Yeah, okay. Oh, you are saying that. Okay, So how about this? Let's implement this operator. Let's implement this operator index. Okay. So ARRI will return the ith element of the array, right? So I'm going to implement it. Index. Okay. Array index, A index. It's a function and it will return what? It's going to return an integer. It will take an integer, right? It will take the array first, okay? A constant integer pointer p, and it will take the index int index. So if somebody wants to use this one, instead of using it, it's going to use this one, a index ARRI. Okay, let me make it a little bit more concrete. Instead of saying cout ARRI, I am going to say cout. Let me find a better, okay, function index ARRI. That's what I'm going to write. Both of them will be the same thing. So I am implementing this square bracket operator, but of course I cannot implement operators yet. I am writing a function for it. Function index. Okay, so that function index takes two things: constant integer pointer and the index itself. So tell me, what should I write here? Return p plus index, right? And the reference. That's the whole implementation, right? Good. So I have implemented. So whoever is using this ARRI actually is running this code. A plus operator, of course, a pointer plus, and a dereferencing operator. Okay? A dereferencing operator. So this is good. So back to my original question. Why did they start addressing this thing from 0, not 1? What's your name?
Soner.
As Soner said, because 0 is the location where AR starts. If I start using 1 to the beginning element of the array, then I have to add, okay, I have to remove 1 from this location. So if I wanted to say, let's make this ARR1, right? If this is ARR1, then I will feed 1 to this function index, and I will add 1 to this p, but I have to take 1 away from this p so that I can return the reference p. So this -1 will be an overhead all the time, okay? So subtract 1 all the time. That's not a good thing. That's why they decided that, okay, let's push this burden to the programmer. The programmer has to remember that arrays start from index 0, not from index 1. There are some languages like Fortran, their arrays start from address number 1, okay, index number 1, but that's kind of inefficient. Okay, yeah.
If I create a union type, then define an array with this union type that includes double char.
Yeah.
So it can it be that some of array elements are double, some of
No, well, each element type is the same union. Okay, it's the same union, yeah. And you are treating the union differently depending on the situations is your responsibility. But each element type is exactly the same thing. Okay? It is up to you. When you say, give me array of 10 elements, each element will be exactly the same. It is up to you how you treat your elements. Sometimes you say that I am going to typecast to a character. I am going to use this as a character. Well, it is here. You are a C programmer. You can do that if you like. But the compiler will give you the same size elements for each of them. Okay. How about this? This one works and this one works too. It is the exact same thing. But I like to do this. ARR1 gets the value of 17. I can write this, right? No problems. This is no problem. How about this one? Function index. Function index ARR1 gets the value of 21. Would this work? So this looks like the answer is no. It doesn't work. I mean, you are returning an integer, or it's a value. You cannot assign a value to another value. Okay, that's a bad thing. But how come this one works? So it looks like ARR index operator does not return a simple integer. It returns something else. You know what it returns? It returns an integer reference. Okay. Once you return an integer reference, it behaves like a regular integer variable. And now I can do this kind of stuff. Okay, this is okay too. So somebody asked, how about the integers? How about the references? Why are we using references? There are pointers, etc. With the references, doing this kind of stuff is possible now. Yeah.
But we can remove start, right? And then
No. It is exactly the same thing. This program compiles and runs and it does whatever we need to do. You are returning a reference to this P plus index reference, the reference position. Okay, now I'm modifying the third element of the array if I like. Yeah. Yes. Are you talking? Okay.
How could we implement this in C?
In C, you mean this one?
Yes.
You can't. I mean, in C, whatever you do is, what you do is, in C you would do, in C, let me show you. In C, that's the right question. How can I do the same thing in C? Because I told you that whatever you can do in C++, you can do it in C too. In C, of course, since you don't have references in C, you can't do the same thing exactly. But if I do this, if I just take this out because I don't have it, and you return a pointer instead of returning a reference, okay, I'm returning a pointer. If I can write this character, okay, I am returning a pointer to the P plus index position, and now I can write stuff like F index ARR7, okay. I am going to assign a value to it, like 19. Of course, this is a pointer and this is an integer. It doesn't work. How about this? Okay, so I dereference it and I use it. Not exactly the same thing, but I mean, see, this kind of a notation is not that weird in C. We do that kind of stuff. Okay, so this is for C only. C language. Okay, I think you had a question back there. You had a question? Same thing? Okay, good. So always ask that question. I mean, how can I do this in C? I mean, there is nothing magical in C++. C++ compilers are written in C. Everything is written in C. Python language is written in C. Operating systems are written in C. All the compilers are written in C and some assembly, right? So you should ask that question. How can I do this in C? What did they do? Because as I said, there is nothing magical. Everything has to be returned. Everything has to be translated to assembly language, machine code. Yes?
What will be if we implemented ampersand ARR1
Address of
Oh, no, well, you address of ARR, you cannot, this one, let's say address of I is an integer. This one returns a value, okay, a pointer value. You cannot increment it. This is a value, it is like incrementing 7, right? You cannot increment 7. This is a value, you cannot make this 7, 8. This is a value, you cannot increment it, okay? It's not a modifiable value. Did you ask this question?
yes.
Okay, you cannot increment it. You cannot increment ARR. ARR is a constant. 7 is a constant, and this is a value, right? It can to increment something. It needs to be a variable. Okay, it needs to be a L value, not R value. Remember, L values and R values. L value and R value. L value is something that can happen on the left-hand side of an assignment operator. L values are the values that can happen on the right-hand side of it. So this is an R value. This is an R value. This is an R value. Okay. To increment something, it needs to be an L value. Yeah.
We can do this operation with C, right? Or
Which one?
the plus plus ARR or plus plus ampersand I.
No, you can't. Because, as I said, this is an R value, not an L value. Okay? Well, I mean, this is an operator, it returns a value. It is same as saying add A to B. This one will return something, and I am going to increment it. Would this work? Answer is no, of course. Because the A plus B is not an L value, it's an R value. Okay? So instead of plus, you are putting ampersand here, ampersand of I. Of course, it will not work. Oh, wait, I'm way out of my time. Let's take some break. After the break, we will continue. Kahve satamayanların burada bırakırsınız.
Hocam kağıt vermedim imza atamadım. Online giremedim. Ben de tamam. Ben sadece 7 falan geçiyordum.
Yarı ders, yarı online falan, yarı iş yapmak falan filan oldu. asansörüne geldi.
Bireyin boyutları benziyor. Değişiyor olabilir. Sen bu en soldan başlıyorsun. Herhangi bir yerden başlayabilirsin. En sağlıklı için gidebiliyorsan bu bilemiyorsan
O da şöyle bir dönüş var.
sıfırlar bile geçen yıllar. Birden geliyor. Şuradan şöyle gidebilirsin. Mesela buradan nerede kaldı?
Adresi oldu. Bugün 11.45 498 oldu. Yani yemek yiyip
Savaş.
Zaten kurtulmak istemiş.
Normal artırıyor B'yi mesela B'yi artıyor mesela A'yı mesela arttırmaya çalışıyoruz. A
bir yer
A'yı
hatta challenge'lara bakmadan challenge'ların cevabı
Pazarda ne kadar iyi pazarlıyorsun görelim. Mevsim alır mı?
normalde A'nın
Hadi tamam çok iyi.
A'yı increment'e
Ama böyle olsun yemiş bir yapması çok tatlı.
Ya bugün de benim yemek günüm ya. Ben yani 6-6.30'da
en zor görevler 160
servisten dolayı.
çok zorlaştıkça zorlar
Hayır kızların birisi
ortalar
istersen yer değiştirip
en kolaylar
onun olduğu gün de sanırım. O yüzden bir tane
A'nın adresi o şey olmuyor mu?
Ben mevkisiyle çok beğendim. Ya öyle çok
O gün sana bir şey aldı diye kızın içeri aldı.
burada şöyle koltuklar arasında iki boş yer olması.
Teşekkürler Emine. Bu arada çıkaramadım. Ayrı bir sana anlatacak mı? Elif'e ilk her sayfadan 1 lira aldılar, 25 lira verdi. Sadece ilk introduction'a. Adam hatta bunu yedi. Hayır, ömür olduğu için 1 lira aldılar. Evet, 40 kurslar falan da 22 yapmak yaptı, 22 lira aldılar. 5 dakika sonra
Görevi yazmak.
en sonunda hayır ettim zaten o tamamen bilgisayarla ben bile yok yaptım. Şuna bak. Bir hayır. Şuna bak. Hiç çıkarttığımız tamam mı? Renksi nerede? Koskoca bir sanat yapıyorum. Bak ben renkli böyle çıkarttıysam eğer bile dört şeklinde siyah beyazlı bir dört şeklinde çıkartmışım değil mi? Hayır işte bunu işaretledim ama böyle çıkarttım. Tamamen bilgisayar. Şimdi Asiye'leri bozmuşlar. Ya ay hiç çözemedi. Ay hiç çözemedi. Çözemedi.
Ama demek ki point olarak
Susar mısın? Bir dahaki birlikte bugün çıkartalım. Ayrıca bir şey istemez. Ayrıca benim bir şey istemez. Sen nasıl hata yapıyorsun? Yalvarırım bana sen çıkar.
6.30'da çıktı. Bir tane servis hediyesi.
Bir şey yok anladın mı? İlk konularına kahretsin yani. İlk saati Allah introduction anlatıyor. Bir saat elimi dokunma yani. Bol korkuyorum. Pazar kaç? Ne zaman çalışıyorsun? Ben 10 dakika 22 lira verdim ben. Umarım elimde çıkı çalışabilir. Çok iyi ya. Notlarını aldım sırf boşa gitmesi para diye.
kağıt şaları kullanmayı düşünüyoruz. Böyle karalama kağıdını kullanmayı düşünüyoruz. Çok boş yer var. Ondan sonra böyle geliyorum işte. Güvenmeyeceğim.
Senin için çıkartacağım tutum sayfa sayısı 137 falan. Asla riske giremedim.
O 137'yi gördük.
Giremedim.
Evet, giremedim.
Kaç sayfa yok?
Açıldı.
Günaydın. Sen söylüyorsun. Hadi
Kaçta yapacağım?
Sana göre. Sorun kaç tane çıkardığım değil. Sorun sayfaların rengi.
Buraya gel, ben göremem diyor.
Evet, bak yatay seçleri o yatay zaten diyor bana. Altı sayfayı güzel diyor, tamam mı? Nasıl asla güvenmeyeceğim kafaya. O da bir açınca o çıkarıyordu, o yüzden çok kötü tekrar. Sonra bir birden şekli çıkartıyor ya. Bir sayfada 4 tanesi. Onu bir de sen tek yap. Çok
Dört
kötü.
kafa çıktı.
Bayağı bana çok güzel.
Valla bana
Nasıl öyle yapacağım? Bir daha başka bir şey asla giymeyeceğim. Bilgisayarı bilerek bozmuşlar. Çocukların özlerine söyleme, tamam mı? Ay beni bitirir ya. Lütfen söyle. Sevişelim altımıza gelmiş. Bir kere erken gelemedim.
Özel şey yapacaktı ya.
Yok bir kere geldim
Yanlış bana. Ben baktım altını öğrendim. Saatleri karıştırdım değil mi?
Valla karıştı. Yol gidiyor.
İşte ben anlamadım yani. Acaba sınavda böyle yaptı. Sınavda böyle 200 nerede duruyor?
Yazıyor, her kaç çıkıyor. Ama öğrenmiyorsun sen. Öğrenmiyorsun. Kıt olmadan bir saat öğrenmiyorsun.
Biraz bilmek için sonrasında çok güzel yerler var. Oraya
Şimdi bana buluyor geliyor.
Kendi yalnız hissediyor. Sana da gelmiyor.
Hocadan yüzüğü çıkardı.
Yalan oldu. İşte o. Çaylasın nerede gelsin.
Ben unutabilirim. Aklımızın yanına.
Çay servisi yapılmadığı için küçük pozisyon. Hani şirin kahvaltı. 4 kişilik var. Çay 3'e alıyor. Biz de geçen işte çay sipariş verdik. 3 aile daha 3 eve daha. Çuvallarla geliyor. Mayıs çayı. Bir sene geçen sene
Hocam, geçen hafta katılamadığım için ısrar
Dersten kalırsan eğer onu getir bana.
Nasıl?
Yoklamadan kalırsan getir. Okay, let's start. So these are the arrays. As I said, these are the aggregate data types. We put together many of the same type variables one after the other in the memory. And using the indexing mechanism and the pointers, we can access their elements by a very, very efficient way. So array declarations, we talked about them. Accessing arrays and etc. I am not going to talk much about it. Array usage. Let's see this simple example. Okay, I have a program. It declares one integer, one array, integer array, another integer. So in my memory is like this actually. So the attendance has started, I guess. Did it? Okay, everybody. Today I'm going to let you sign your names on my attendance sheet after the lecture if you forgot, if you had some issues with the online attendance. After that, I will take away this paper, okay? Everybody has to do it online. I forgot, I didn't know, I blah blah, I will not accept any of those excuses. Unless you don't have a cell phone and with this smartphone, or you don't have a friend who has a smartphone, then you talk to me after the class. Okay, last time when I told you to enter your names, most people said that the network is not accessible. The next day I asked our Osman Bey, who is responsible for all the networks and everything. Did anybody tell you that the wireless receivers in the classrooms are not working? He said no. I don't understand. I mean, when it comes to complaints, you are number one, but you are not complaining to the right person. If you see something is not working, something is broken, something is out of order, you go to the secretary upstairs, then you report it, okay? If you don't report it, who is going to tell them that the wireless system is not working? They don't have to check it every day. Okay, I guess they fixed it. I told them that the wireless is not working, and they fixed it. So I have 3 variables. So everybody's okay? I have 3 variables. One is I. Immediately after I have 5 1 2. Let me do it this way. Okay, let me do it this way. So this is scores, and then I have finally max. Okay, and it says enter 5 scores, and first it returns score 0. It is score 0. Whatever the user gives is entered into score 0. So let's say if he entered 2, then max is score 0. Max is going to be 2. Then at every loop iteration from 1 to 5, not 0 to 5, but 1 to 5, because the element number 0 is already done. Then I am going to enter them. Okay, every time I enter it, I compare it with max, and if it is greater than max, I am going to change it. Let's say it is 7, 12, 14, and minus 5. Of course, it's going to be 12 here. Okay, so this will be the memory. So and finally I will be what at the end of this loop, number 18. Okay, line number 18. What would be the value of I when this loop is done? What would be the value of I? Is it? If it is 4, then this loop will continue, right? 4 is less than 5. So the first time this condition is false is 5. When I is 5, this loop will end. So it's going to be 5. Okay? And then I would print these out from 0 to 5. I will print them one by one, and I will print the difference between the maximum and the score. Okay, so an example. So if the user enters 5, 9, 2, 10, and 6, okay, so the highest will be 10, and the difference would be these. So simple loops with the arrays. Nothing new in this program. Okay, this would work exactly the same as in C. The only difference would be the C in stream extraction, stream insertion operators. If you replace them printfs and scanfs, it will be exactly the same thing. Okay, so loops and indexing with the arrays, they always use together. Okay, if you are not using the indexing mechanism of arrays, then you shouldn't maybe use arrays, because arrays are meaningful only with the index operator. Okay, index will start 0, not from 1. Starting from 1 looks like meaningful, but I mean, if you have 5 things, this is number 1, not number 0. But index doesn't mean number. Index is index. Okay, we talked about this, and usually we do this kind of stuff. Okay, we don't say int score 5, we say int score number of students, so that we know what 5 means. Okay, but it's the same thing. It's a constant 5, but we are giving it a name, number of students. When we later change this 5 to 10, people would understand that it is 10. Okay, it is number of students changing. Since when you give this number, when you define this like number of students 5 here, your loops will be meaningful too. So your loop will start from 0 to number of students. Okay, so it is not from 0 to 5, it is from 0 to number of students. Readable, okay, it is more maintainable, etc. Okay, like this one. And last index is like this one. So don't use magic numbers. You don't use magic numbers in your code. Always give names to your constants. Okay, some people say that how come nobody is giving it a name, a constant 0? Our loops start from 0, right? Why don't we give a name to this 0? Well, 0 has already a nice name. It is 0. It is the first element of the array. Everybody knows it, but we don't know the last one. Okay, C++ says that I have a new way of accessing your arrays. Okay, it is called range-based for loop. C++ 11 edition. It is not in C++ 98. Okay, It's a for loop, and it works this way. Data type, variable name, and the array. Okay. If my array is like this, 4 elements in my array, okay, you can define a loop like this. I have a variable index. It will start from the first element of the array, and it will iterate over the all the elements until the last one. And every time it will be assigned the element of the array. So in the first iteration, x will be assigned a value of 20, then 30, then 40, then 50. Okay. So when this runs, it will print 20, 30, 40, and 50 on the screen. I mean, if you like to write this in the classic way of C++, this would be the thing. For integer I from 0 to 4, okay, plus I, x, okay, local x get the value of ARR I and print x, and after that a space. That's it. So instead of indexing yourself, this new, okay, range-based for loop, okay, mechanism handles the indexing. Try to use it whenever you can, okay. Instead of writing loops like from 0 to something, use it this way. Okay, range-based for loop is more complicated or more detailed than this. As you see, you might say that, how about if I like to run this from 0 to first 5 elements, or from 0 to half the elements, or from 0 to only the even numbered element, etc. There are ways of doing it. Where is my C++ com? Okay, range based for loop. Make a search on it. Okay, yeah, okay. Oh, this is help. I don't want the help. No, where did it go? I don't wanna go to the forum. I like to get the, okay. Let's do this with somewhere else. Okay, here it is. So syntax is this. Okay, range declaration and range expression, and let's see some examples of it. This is the, remember vectors? It works with vectors very, okay, this is a good one. Auto IV. I don't have to say what the element type of I is going to be. It's going to be automatically deducted. It's going to be automatically deducted with this expression. Okay, auto IV. So I will be automatically integer I, right? It will be printed like that. And you can do that kind of stuff. See, this is a range phase for loop 2. It looks like there is a constant array here. See, it's an array, right? It's an array, and it is doing that. Come on. Okay, what else? There is another one. These are for a string. I can do the elements one by one. Okay, maps, we did not see them yet. And if I like to do it with the, other, no, here it is. No, here. Like the indexes, you can say from C++ reference, another good way of doing this kind of reference stuff. Okay, begin expression, end expression, and these, let me show you some examples. Okay, good. How about this one? What does it say? It says I have a vector and I will be a constant reference to each of these elements, right? I promise I am not going to modify I, because if you modify I, the elements of V will be changed, right? And I am not doing any assignments. It's like I is not a reference to this one. It's not like copying, right? We will talk about this later. Don't get scared. Okay, and I am going to, yeah, auto and V size, and see this one? I am getting the size from V, okay? And every time I am using this N, declaration type of V, it uses that information in here. And these are some of the outputs. Anyway, somebody smoking out there? Arkadaşlar burada sigara mı içiyorsunuz ya? Sigara mı içiyorsunuz? Ha? Kim sigara içiyor? Burada sigara kokusu geliyor. Okay, you look this up yourself, and you will find that many other uses of this range-based for loop. Later they changed it a little bit with the other C++ versions, but basically this is it. Try to use it all the time. So this is something new. It is not about arrays, but it is about for loops, and it's called range-based for loop, and we are going to use it in many ways. So, by the way, maybe they told you that ARR is a simple pointer, right? Integer pointer. How does the compiler know the array size by looking at this ARR then, right? If ARR is a simple pointer, right? Just an integer pointer, then how come the compiler can figure out the size of ARR? How come the compiler knows that there are 4 elements in it? Okay. And the other thing is, let's say I have a function, okay, a very simple function, a void function f, and that f is going to take, let's say, integer a, an array, right? I will take an array, and I'm saying this: for auto I, a, cout I. Okay, nice, right? Let me try to write it auto better way. Okay, this will not work. Okay, because when you send an array to a function, only the integer pointer goes to the function. What was the rule? You cannot send an array to a function by itself. You need to send its size too, right? That was the rule. The rule is still valid. This will not work, but this works, because the definition of ARR and this range-based for loop are in the same scope. The compiler somehow, this kind of a little bit complicated, figures out the size of ARR, okay? Figures out the size of ARR somehow. So it will work here, but if I try to send this to this function f, ARR is an integer thing, right? This will compile, but this will not work. You're going to get a error message saying that I cannot determine the size of this. It's just an integer pointer. Okay, it's just an integer pointer. But this range-based for loop works very well for the vectors, with no problems. So if you have a function like this, void, let's say G, let's say it takes a vector of integers, okay, let's say V for auto I V cout I. works perfectly because V is not an array. It's just a like a type, like a double, like a string. Okay, it's a vector and it's an integer vector. I don't know its size, but V knows its size. I can ask the size of the V by asking, what is your size? V dot size, it will tell you, and this will work. Okay, that's why we like to use vectors instead of arrays most of the time wherever they are useful. Okay, somebody asked me last time I talked about the vectors, how can you do two-dimensional vectors? Because we had two-dimensional arrays, right? The answer is very similar. If this is a vector of integers, integer vector, okay, I don't know its initial size, this is 0. I can later change its size. Okay, what does it mean? I have a vector, each element of this vector is an integer, right? So logically you could do this. I have a vector, each of the elements of this vector is another vector of integers. Okay, so integer, it is vector 2D. Okay, so this is a two-dimensional vector now. Two-dimensional vector now. Okay, it's a two-dimensional vector, and how can I use this one? I would use it this way. Remember, this is a vector, and let's say this is of size 10. I can do this. v2d dot push back integer vector. How could this happen? Why? Well, what did I say? This v2d is a vector of vectors, right? So each element of these v2d is an integer vector. So I push back an integer vector to it. So I can say things like, okay, C out v2d element 0, element 2. Okay, this one will give you this vector, okay, and this one will index it. Okay, anyways, we are going to look at these later, but I mean, this vector class is very nice, very reusable, very flexible, and we like to use it all the time. Yes?
Is there a way to implement the function f without using vectors?
Which function f? You mean this function? Without the vectors?
Yes.
Well, I implement, you are saying that I am going to use auto. I think there might be a way, but I'm not sure. I think you can say that use this one. I am going to give you the size of it too. Just look up the documentation. There should be one way of doing it. Auto. Since the problem here is that I don't know the size of I cannot know how it ends, where it ends. But I think there is a way of saying that you start from here and you end it here. There must be a way of doing it. But I'm sure it's not readable. Yeah.
If you use C++ library array, include array, do we have to pass argument, pass the size as argument?
Yeah, I mean, you mean this one? Yeah, you definitely need to pass the size of the array, or at least pass the portion of the array that you're going to use, and you will have to write things like I have a integer I that will start from 0, I less than size, and plus I. Yeah, that's the readable way of doing things. Now it is okay. Okay, but if you use vectors, it's going to be nicer. The thing is that some people say that Well, I am passing a simple integer pointer and a simple integer now here. It's very fast. Two simple things, a pointer and a size. You are passing the whole vector like that, and vector is a very large thing, right? It has to be copied because this is called by value, right? I am copying the whole vector now. Okay, if this vector has size 1000, 2000, 1 million, then you are going to copy megabytes of memory space. That's going to be wasteful. So what is our answer? Our answer is, okay, I'm going to call by reference. When you do the call by reference, couldn't do it. When you do the call by reference, only a reference is copied. This is very cheap. Okay, it's very cheap because you are passing the actual thing. But now there is a danger of modifying this V. To prevent that one, what are we going to do? We are going to say G takes a constant, okay, constant vector reference. Now, it is both call by reference, but it's a constant reference. Nothing is going to be changed, and it's very efficient. So the rule of C++ is this, okay? And we follow this rule strictly. If you are passing a simple type, integers and doubles and booleans and etc., you use call by value, okay? But if you are going to pass complex objects like strings or vectors and that kind of stuff, other than the fundamental types, then you pass them constant references, okay? Constant references for any other type. Okay? Yeah.
On the website, if we call the array a call by reference, does it make a difference?
You mean how do you? You mean this one? How are you gonna do the call by reference array? Array is already a constant name, right? ARR is a constant pointer, right? How are you gonna do the ARR with a call by reference? Maybe if you do it with a constant call by reference, it would work, but it would be exactly the same thing. ARR name is a simple pointer. So since it's a simple pointer, we use call by value for that. If you like, yes, you could use a call by reference, but it is not going to make any difference because you'll have to use a constant call by reference anyway because it's a constant thing. Good. Any other questions? What happened to you guys? I mean, so it's good, okay? So that means that you studied or okay, maybe you got bored in the other lectures? Well, okay, whatever. So we talked about this, arrays in memory, we talked about it. Yeah.
Can I ask a question to slides before?
Which one? Here?
Pushback ID. V2D, pushback ID. How it's no size of, where we know size of vectors of vector integer length should be IV's length.
Well, I mean, no. We don't talk about, as I said, object-oriented programming is something about abstracting away the details of how the things work. We don't think about those, and we don't have to think about those. All I know is that V2D is a vector of this type, right? It's not vector of integers, vector of this type. So when I push back something to this V2D, it has to be this type, and IV is of this type. I mean, if I scratch this out and type integer here, if I scratch this out and type integer here, this is going to work, right? IV is an integer and V2D is an integer vector, and it works. Of course, this last line will not work anymore because V2D0 will return an integer and indexing doesn't work with integers, right? So you think it this way. I have a vector of something, vector of what? Vector of integers, and this will work. By the way, the newer standards of C++ handles it, but be careful about this. You should put a space in between these two, otherwise the compiler will think that this is a stream extraction operator, and it will give you a compiler error saying that what are you doing? What's up with this? Yeah. Continue.
I understood pushback as popback.
Well, you can do the popback too. Well, with the popback doesn't take a parameter. It just returns something for you and you need to assign it. Good. Okay. Let me move on. Okay, when you declare an array like integer a6, we know, okay, this is our memory and these are byte locations. Starting from some location in the memory that compiler makes a decision on it, it is very difficult to change it and you shouldn't do it. Okay, compiler says that my integers are 2 bytes. Depending on your architecture, compiler, operating system, whatever, my integers are 2 bytes, and I'm going to store the first integer here, the second here, third one, fourth one, fifth one. Okay, it goes that way, and indexing will work this way. With only 16 bits, okay, with only 16 bits, okay, 8-bit and 8-bit, you can have an integer as large as, if it is unsigned, 2 to the power 16, right? Okay, so this is our capability of our integers. Very small integers, but okay, for the 16-bit computers, okay, up until the 2000s, people used 16-bit integers. It works this way. And the compiler guarantees that there will be no space between the element number 0 and element number 1. It is consecutive, right? They will come one after the other. If compiler doesn't guarantee that, then this will not work, right? A plus 3, the reference, remember indexing works. I mean, if there are spaces between those and random spaces, that indexing mechanism will not work. Okay, remember this notation? Okay, if I say my integer pointer a, yeah, okay, it will start from a is an integer pointer and it points to this location, right? And from 0 to 6 I am going to do this, okay? I will increment I by 1, and every time this loop runs I am going to increment this pointer, and I am printing this out. What does it mean? It means this pointer at the beginning will point to the first element of the array. In the second iteration is going to be point to the second element, third element, etc. At the same time I am using this same indexing thing, I, to print it out. So this will print the exactly same thing. It will print whatever these values are. Because of this rule that says that there cannot be any spaces between the elements of an array, this plus and index works. Otherwise it wouldn't work. Okay. When you say I will have an integer I, an integer k, a double d. Okay, I need these 3. I don't know where they are stored in the memory, and I don't know if there is a space between them or not. Okay, I cannot make these kind of assumptions in C or C++. Of course, there are some compiler switches that will give you the power of making these decisions. There should be any space between them or more space and etc. Compiler may choose to put some space between these 2 integers so that code runs faster. For example, let's say your integers are 32-bit integers, right? Your integers are 32-bit integers, but your machine is a 64-bit machine. So it makes sense to use 64-bit of whole integers for 32 bits. So you may say that, okay, I'm going to put some space after the integers. So that will make my code faster, larger but faster. So these kind of decisions are done by the compiler, and I don't care. I don't make any decision based on the space between this I and k in memory. But in arrays, you are guaranteed to have no spaces between between elements. They are consecutive. Okay, good. We talked about this. Initialization of the arrays are done this way. We already know that one. And you don't have to put this 3 in here. The compiler is smart enough to make a count of this array, initialization, and put a 3 in there too. Okay, that's called auto initialization, like that one. Arrays in functions. Let's see some functions that uses arrays. For example, a function that takes an integer array and its size, of course. I didn't have to use this notation. I could have said, I am taking a constant integer pointer. I promise I'm not going to change anything with this a. Okay, so it's an integer array a and size, fill up. It looks like, what is the size is declared in the size of array a. User will type in the, so it looks like I'm going to read some numbers from the keyboard and I will put them in inside this array up to the size of size. Okay, so from 0 to size, I enter these numbers from the keyboard. Size doesn't have to be the exact size of this array. It has to be either equal to the size of the array or smaller than it, because I may choose to fill the first part of the array. Okay, so simple stuff. I think I am out of time a little bit. I don't know what I mean by a little bit out of time. I am perfectly out of time. Maybe I should not hurry up, and maybe I should finish this tomorrow. I will stop at this point if there are no questions. Are there any questions? So, how many people did not sign their names? 1, 2, 3. Okay. So tomorrow I am not going to let anybody sign their names. Please use the online form to sign it.
Ya nasıl ötüyorsunuz? Tamam o. Hocam bitti. 10. onun onu mu buldun? Arkadaşlar başa yoğun yazan yerimiz kaldı. Başkanın yeni iddiası
Vektörü bilmediğim için soracağım. Hocam, internetten ben kod baktığım zaman insanlar